we use /30 as the subnet mask. /30 means 255.255.255.252. This means that in this scenario, now we have two types of networks. The first type of network for the 7 rooms that has on 30 PCs has this subnet mask 255.255.224 means /27. And also for the scenario B, the rooms with 2 PCs, now we find this subnet mask is suitable. This means that in this scenario we are using variable length subnet mask, variable length, okay, subnet mask, or VLSM. Why? Because we have two type of requirement. In the previous scenario, previous examples, you learned about the single length subnet mask. For example, you know that in previous scenario, I configured this example. The first example, let me write here. The first example had this requirement. We needed 2 network, okay? In each network, we have 126 hosts. As you remember, the subnet mask we find for these networks is 255.255.255.128, okay? And here we have only one subnet mask. We call it SLSM, or single length, okay, subnet mask. Or in some cases maybe you encounter with this word FLSM, or fixed length subnet mask. Both of them are same, okay? In the next example, this is example 1, okay? Let me to write here the example 2. In example 2, we had this scenario, 4 network with each network 62 hosts, and you know that we calculated the 255.255.255.192 as the subnet mask, and again here we have SLSM. But in the example 3, this is the example 3, we have two type of requirement. Let me write here. In example 3, okay, this is example 3, we needed 7 network. In each network we have for example, as you can see here, 30 IP address, or 30 hosts, okay? 7 networks with 30 hosts, 30 PCs. And after that, beside of that, we have 7 network, okay, with 2 IP address in each network. Let me write here. This is the second requirement. 7 network with the 2 IP address, 2 hosts in each network. For the first network, we find 255.255.254, and for the second requirement, we find 255.255.255.252. That's it, okay? This means that in this network, in this scenario, we are using VLSM, or variable length subnet mask. This means that in our networks we are using different length of the subnet mask, because we have different requirement for different networks. Okay, also let me to show you the process that we did. Here you can see the process. Here, as you can see, in example 3, we have a building with 14 rooms. As you know, 30 PCs reside in 7 rooms and 2 PCs in other 7 rooms. The task is to subnetting 192.168.10/24 for these rooms. Look at here, this is the solution. We have 7 networks with 30 PCs. This is the step 1, and the step 2 is 7 networks with 2 PCs. Let me first to solve step 1. Here you can see the calculation of the requirement. 2 to the power of s should be greater than or equal to 7, and after that 2 to the power of h minus 2 should be greater than or equal to 30. S should be greater than or equal to 3. H should be greater than or equal to 5. S plus H, 3 plus 5 equal to 8, and we need 8 bits. Because we have 8 bits, we can solve it. And here, as you can see, again we have the same process. Triple S 192.168.10/24 by default has 8 bits of hosts. Now we subnetted this 8 bits, 3 bits borrowed from the host bit, and we give it to the network part. We call them subnet bits, and because of the subnet bits can be from 000 to 111. Here again we have the same process. Finally, we find we designed 7 subnets. We did it, And after that, here now we have one spare subnet. This is a subnet mask. Because of that, now we can use this subnet 192.168.1.224/27 for 7 network with the 2 PCs. This is the next part of this scenario. We have 7 networks with in each network 2 PC, and we are subnetting 192.168.1.224/27. And look at here, we have 27 fixed bits, and only we have 5 bits. Okay, 5 bits for host. First, let me first calculate the requirement. 2 to the power of s should be greater than 7. S should be greater than or equal to the 3. 2 to the power of h minus 2 should be greater than or equal to 2. Because of that, the h should be greater than or equal to 2, and because of that we need s plus h, means 3 plus 2 equal to the 5 bits, and because here we have 5 bits, we can design this scenario. Again, from these 5 host bits, I borrowed 3 bits for subnet, and I gave this part to the network, and here we have triple S, and with triple S we can create 8 network, and in each network we have 2 bits. In 2 bits means the host bits can be 00. 00 is using for the network address, 1, and also 11. 11 should be used for the broadcast address, and we are using 01 and 10 instead of the HH bits. And here we have 2 hosts, and finally we created 8 networks, but we need only 7 networks. Because of that, again we have 1 extra networks, 1 spare network. We can use it in future. Look at here, 192.168.1.252/13 now is the spare network. This is the third example, but at the final scenario of this video, I'm going to give you one extra scenario, and in this scenario again I'm going to configure or I'm going to design a network with triple requirement. In this video, in this scenario, we experience a network with 2 requirements, 7 PCs in 7 networks with in each network 30 PCs, and also 7 networks in each networks, for example 2 PCs. But in the fourth example, I'm going to give you one network with 3 type of requirement. Let me show you what is the requirement. Example 4. Okay, this is the last example about the subnetting in this video, but it's so important to for understanding all of this exam. Look at here again we have the same network. For example 192.168.1.0/24. It's not so important, but we need to subnet these networks with these requirements. We need one network. Let me write here one network. Okay, we can use multiply one network with 126 hosts and or PCs, and also we need 3 networks with in each network we have 30 PCs, and after that for example we need again 3 networks. In each network we have 6 PCs. Okay, these are our requirements. Let me start solving this or designing these networks. You know that here we have 3 type of requirements, and it's better first designing the network with the more PCs. For example, we can design first this network, one network with 126 IP address. After that, we can design the next network, 3 networks with the 30 IP address requirement, and the last part of our scenario, the part C, is designing the 3 networks with in each network 6 IP address. Let me start with the first requirement, 1 network and with the 126 hosts. Let me write here network. We need 1 subnet. This is the subnet 1. We have 1 subnet, and also for example in this subnet we need this number of hosts, 126. Again we need to find their requirement. Let me calculate it for you. 2 to the power of s should be greater than or equal to 2. Why? Look at here. Yes, The requirement is one subnet with 126, but you know that we are designing one subnet with this amount of hosts, okay, but we need another subnet for other part of networks. For example, actually we have two subnets. The first subnet with 126 bits, this is for requirement A, and also we have the next subnet with 126 bits that we can again subnetted this new subnet for other networks. Because of that, let me to use the 2 to the power of s greater than or equal to, and this means that the s, okay, or subnet bits should be greater than or equal 1. This means that we need only one bit for subnet. After that, in the next part, 2 to the power of h minus 2, okay, should be greater than 126. Look at here, greater than or equal to the 126. This means that we have in host bits, we need minimum 7 bits for this amount of for example, a host addresses 126. Let me to design, but first let me to calculate s plus h. 1 plus 7 equal to 8, and this is less than the IP address, the host bits that we have 8 bit. Look at here. Here we have 8 bit of host. Because of that, with this design, we can start the configuration. We need 8 bits, and also we have 8 bits. Let me to start the design. You know that the first step is that 192.168.10/24